Hi everyone, I'm Ayush Sharma and I'm from GDG core team and lead at DST. I welcome all of you on this awesome session on blockchain called Blockchain 101 by on Tezos. So powered by Tezos India Foundation and GDG Gwalior. So before starting, let me tell you some few important points which should be taken in point. So this is going to be a 2 days workshop today and tomorrow at the same time on YouTube at on 1 p.m. at 2 3 p.m. In addition, there will be a certificate for attendees by Tezos India Foundation. So you will have to fill the form to claim it, which will be sent out in the live chat at any random time. So make sure you have an eye on live chat. Apart from that, if you have any questions, you can ask in the live chat, and there's no foundations in that. Make sure you follow the guidelines. So I won't be taking much of your time. Let me introduce our speakers, Mr. Om Malviya, President of Tezos India Foundation, and Mr. Jignesh Vasoya, Tech Lead of Tezos India Foundation. They'll be taking the session both the days, today and tomorrow. So now over to our speakers. Stream is all yours, sir. Thank you.
Hey guys, hi everyone. I'm Om Malviya, President of Tezos India Foundation, and it's a pleasure to be here and to facilitate you this workshop. And we'll be taking you through the basics of blockchain, going forward with some live and some practice. We're developing some smart contracts on top of Tezos. So I'm gonna tell you just a little bit about Tezos India Foundation, what we do, just a general overview. Then we have our other core team member, Jignesh, and Jignesh will be taking you through in today's workshop about basics of blockchain and helping you understand the jargons and the technology behind it. So just pay attention, stay live, and let me share my screen so that I can. So, hey, we are Tezos India Foundation. Tezos India Foundation is a non-profit entity, which and the goal of Tezos India Foundation is to support and promote the Tezos ecosystem growth in India. Tezos is mainly a blockchain platform. So, in some time you will be learning about what blockchain is. But just to give you a basic idea, blockchain is a technology, and there are different blockchain platforms to which enables you how to use the technology in such way. For an example, you have Android, you have iOS, and then you have different frameworks for developing on Android, and you have different frameworks for developing on iOS. In the same way, Tezos is a blockchain where you can develop blockchain applications in a framework which is suggested by Tezos. And there are multiple blockchains such as Ethereum and EOS, many blockchains out there. And each blockchain has its own purpose, some set of features that it enables, like Bitcoin enables mainly the value transfer, where you can send Bitcoins from one person to another person. And other blockchains such as Ethereum and Tezos, they enable smart contracts. So you can send money from one person to another person, and also you can write smart contracts, which are conditional contract, and they are activated according to certain conditions. You'll get to know more about that, but let's move forward. Tezos India Foundation is a non-profit entity, as I said before. We have some pre-identified goals. So one of our goals is education. Education to achieve this goal, we partner with universities, we partner with local communities, we organize workshops, and we organize seminars, conferences. Our goal here is to educate and discover new Tezos engineers. We want to teach developers and students about this technology, the blockchain technology, and then we want to train them, and we want to teach them that how you guys can use this technology and how you guys can build applications and hone your skills and deploy those applications, develop those applications on using Tezos blockchain. So mainly we are very Tezos centric. Whatever we are going to teach you, whatever we're going to train you about, is going to be about how can you build blockchain applications, but using Tezos. This is one of our example, one of the first workshop that we organized in Delhi Technological Universities in Delhi. And here you can see we saw good participation. One of our second goal is meetups. So India is a huge country, and we also have a very different set of audience and very different set of community member. So in the blockchain technology, or in the Tezos blockchain, we have a very wide community which consists of corporations, business people, technology people, senior developers, students, college developers, and normal people. So it's a huge community. So we organize meetups in all the major cities where you get to meet with other people in the industry, such as corporates or business people or accounting people or the finance people, and the students and developers all get into one room. They learn about what Tezos is. They learn about what Tezos is doing. They learn about how you can be involved in the Tezos, and then they network with each other. So that enables a lot of opportunities for developers. That also enables a lot of opportunities for corporations, for business people, for finance people, so that they get to meet like-minded people, and they can leverage each other's skills and network. This is how a meetup look like, where you can see many executive people, you can see many students, and you can see media people, and they are all eager to meet and network with each other to learn together and to grow together. Now, one of our third goal is partnership. So here what we do is we partner with startups, we partner with universities, we partner with local developer communities such as GDG Gwalior or GDG Bangalore. And through our partnership, and we provide all these communities, all the organizations, startups, projects, and all the help and resources which can help them to build their next idea, next project, or help them research about on top of Tezos. So this way we bring companies, startups, projects, developers, and all this different huge variety of people and companies on top of this ecosystem, so that they can build next level applications or next generation project on top of Tezos. This was one of the event that we partnered with. It was Genesis DevCon, which was held in IISc Bangalore. It was one of India's biggest blockchain developer conference, and there we talked about the how companies and the corporations can use Tezos, what are the benefits of Tezos. We also delivered a workshop on Tezos for everyone, for senior developers to student developers, a wide variety of people, so that they can learn how to build applications on top of Tezos and how they can use those applications to maybe build their startups, to maybe use in their companies, or maybe for their next idea. So that's how that works. Now we are talking to you guys as a developer community. So what are the opportunities there? So Tezos has a very robust and vibrant grant ecosystem. So in grant, what we do is all the developers who wish to contribute to ecosystem, if you want to build, let's say, something which can benefit the entire community, or if you wish to research about this protocol, if you wish to build something which is not there. For an example, let's say you want to build a JavaScript library for some functionalities, you want to build a Python library for some functionalities, or if you want to build a new language, or if you want to add, let's say, C++ language support to build application on top of Tezos. So for this kind of open source contribution, Tezos also have a very robust grant ecosystem where we provide grants up to $50,000, which is a huge amount for exciting projects. But the grants come for people who, let's say, are experienced developers, or who really has an idea, who can pull off a complex project or something which can further enhance the developer community in Tezos. For for developers who don't have a lot of prior experience and who are just starting out, if they want to participate in this ecosystem and also get incentives, get rewards for the same, we organize a lot of hackathons. So if you are just new developers who you haven't worked on blockchain before, you have some basic understanding of languages such as JavaScript or Python, you know basic coding, so you have basic understanding of blockchain, then you can participate in our hackathons where we have different tracks and we have mentors, and we take you through this entire journey of giving you resources, helping you solve your doubts, and then at the end we help you submit your project. And that way you get to learn a lot more about about the Tezos, and you get able to build your project. And if your project idea is nice, and if you have put a lot of efforts and it has a nice use case, which can further evolve into a business use case, or which can evolve into something good, then we also uh, put a lot of good prizes to reward your efforts, to reward efforts of each participant. Apart from that, you are always winners in our hackathons, because those who are big winners, they get prizes. But every participant who submit their projects, we have a lot of goodies. We have many merchandise. We also run many programs such as ambassador program and other programs, so that you guys can stay in touch with this ecosystem, and you can keep benefiting from all the activities that we do. This is one of the example of a hackathon which we recently organized, and we concluded this hackathon last week only. Some of you guys may have heard about it. Days India Harappa. It was India's first online Tezos hackathon, which was 1 month long, and we saw many great participation, and many great people, many developers and students submitted their projects. Soon we are going to announce the results, but this is one of the example, and you can also look at the prizes, and you can go to the website tezindia.online to see how Tezos India Hackathon was being organized and how do we do it. Apart from grant hackathon, the best thing that you get from this ecosystem is your network building. As a student, as a developer, if you want to grow faster, if you want to also enhance your soft skills, it is very recommended to get involved in network building. So the Tezos is a decentralized global project. So you have many communities of Tezos, like Tezos India, there is Tezos USA, there is Tezos China, there is Tezos Southeast Asia, Tezos Korea, Tezos Japan, London, Paris, Malta, Switzerland. So many different communities, and all the communities are very interconnected with each other on many discussion forums, and all the projects and startups and the hackathons, they also get very connected in their ecosystem. So you get to learn, and you get to build your network in the global community. You get to learn from other people from around the globe, around the world, and see how they approach to a certain problem, or how they what kind of practices they use in their development. So those people learn from you, you guys learn from them, and it's a win-win for everyone. And it also uh, enhances your soft skills. So that is one of the opportunities that you get from being in the Tezos ecosystem. So this was an overview about Tezos India Foundation. I hope you guys got an idea that as a foundation, what we do, we are non-profit, and what we want to do is we want to get you guys into our ecosystem. We want to train you about how to build applications on top of Tezos, then we want to organize hackathons for you so that you guys can participate. And if any of you has good idea, good project, then we will help you to take it to next level. If you want to convert into, if you want to convert it into a startup or a business, we help you there, guys. Or if you have any good idea where you want to build something for the community or any developer tool or something like that, then we can also help you to apply for a grant. So Tezos is a very vibrant and emerging ecosystem. I would recommend you guys to follow us on Telegram, Twitter, and if you want to keep developing, you can join our developer Telegram channel so that you can learn and you can always ask any questions, any issues, any bugs that comes to your mind. This was about Tezos India Foundation, and if you have any doubts, you can ask. You can ask me right now. If you have any doubts, then you can drop any comments. I'll be happy to answer them. And from the next sometime, Jignesh will be taking over and will be taking you through the introduction to blockchain today. And I hope you guys ask all the questions that you have. Ask plenty of questions, and if you have any doubt, let us know. Join us, follow us, and there is many opportunities and many activities waiting for you guys. We're really happy to be part of this session. I'll again be here for a minute. If you have any questions, then you can ask me right now. I hand over to Jignesh. Okay, I hope you guys got the basic idea. So now let's start with what exactly the blockchain is. If I hope some of you guys have gone through the resources and material that we gave you earlier. As this is a very short term session, usually it takes an entire day to explain that whole concept of blockchain. But I hope you guys pay attention and ask us any question if you have. Thank you for attending this session once again, and I'll hand over now the stage of the voice to Jignesh. Jignesh is a very experienced. Okay, so we got one question: how Tezos is better than Ethereum? Tezos, you could see what Tezos try to do and what Tezos has achieved to do is solve the issues that were faced by Bitcoin and Ethereum. Tezos is better than Ethereum in many ways, such as Tezos has one of the best proof of stake network. We'll get to know what is that. Tezos is way more secure than Ethereum because it enables formal verification, which is a very secure way to write smart contracts, and also it has on-chain governance. So there are many basic complex terms. Basically, what I would try to say, conclude your answer in a very short term. Tezos is more innovative. Tezos is more secure, and Tezos addresses the problems that are being faced by and that have been faced by Bitcoin and Ethereum. So there are many problems that Ethereum and Bitcoin have faced previously, and Tezos tries to address them. So you'll get to know more about how that works. But first, let's learn about blockchain. One more question is, sir, do your organization teaches how to contribute to open source? Yes, if you stay active in our developer groups, you can always ask us questions. Diktesh is a great guy. He can always help you regarding how to contribute to open source and what kind of skills you need to learn, or what everything about how to do it and what to do. Okay. Thanks again, guys. I'll hand over this to Jignesh. Jignesh will be taking you through the introduction.
Sure. Yeah. Thank you. Hey, hi guys. Good afternoon. Thanks for joining. Right. Yeah, so before we just start, right, I just want to tell, right, keep it interactive. I can see the comments here, right? So whatever doubts, anything, right, you just kind of post it there, and I'll try to answer all of them, right? Before we end the session, I am like sure I'll be answering all of them. Correct. So I think has already answered how Tezos is better than Ethereum, right? Now, next would be, yeah, uh, does your organization teaches how to contribute to open source? Yeah, like we teach how to contribute to open source, or how you can like be writing a code tool, right? Any library for like, so Tezos platform, right? I'll be covering that in a later, but it's a kind of open source platform, right? And it's a decentralized platform. Anybody can join, can work, can improve on the platform, right? So yeah, we will teach you how to contribute to open source platform, right? Yeah. Then Tezos is a private or public? Tezos is a public blockchain. Yeah, cool. So okay, let's get started then. I'll be sharing my screen. So how many of you have Bitcoin, or already holding Bitcoin, right? Or have you heard about Bitcoin in past, let's say 2 or 3 weeks? Anybody? You can post it in comment. I know it's odd, right? Doing this kind of a session. I am generally like I love to interact with people, right, in a live session. But yeah, this is again new for me as well. So yeah, yeah, cool. Okay, so as you have heard, right, in the recent, I think the last 3 or 4 weeks, you might have come across any of the news, right, that Bitcoin is rising. Correct, and yes, it is rising. It was around 4,000, not 4,000, but it was around 5,500 or $6,000, right? Yeah, just like 1 month back in March, and now it is like almost touching 10,000. So that's like double, right? But this is not a marketing or like financial advice, right? I'm just giving you the idea. So that's not all about Bitcoin, right? So let's get started. Yeah, where's my PPT? Okay, yeah. So as you might have seen, right, most of the people, right, even if they like, this is very popular. Any person, right, who just owns, let's say, 0.0001 of Bitcoin, right, and he'll be like, okay, I'm a crypto expert. I know. Okay, 25 दिन में पैसा double, right? मेरे पास एक scheme है, all those kind of thing, right? But yeah, Bitcoin is not like that, and we are not here to talk about, let's say, money aspect of the Bitcoin, right? But yeah, like, so you'll find this kind of people in the market, right? So be aware of them, right? And then there are then people that, okay, I'm in it for technology, right? So when the market goes down, you'll find these people saying that, okay, yeah, I was not here never for money, like it was for technology and all, right? So yeah, you'll find all this kind of people a lot in let's say crypto and blockchain development world. Yeah. Okay, but yeah, so let's actually see what it is, right? How it works, and what is in it for you guys. Yeah. Okay. So yeah, can anybody tell what this is? Anybody in the comment section? I'm waiting for your comments, guys. What is this? The whatever screenshot that you are seeing, right? All I say is the reacts, right? Emojis in the chat. Yeah, cool. So see, this is how the internet used to look like, right? When during the early 90s, right? When the internet was like kind of born, right? Out of that private network of US military, right? So after that, like this was amongst the first few websites, right? That used to look like. So yeah, Bitcoin and blockchain development, right? We are still in this phase, right, where we have all the very primitive items. As of now, if you see, right, the website and everything looks fancy, right? For that matter, we are on YouTube, right? Nobody would have ever thought that we'll be doing all this kind of a live session over the YouTube, or everybody will be uploading video, right? And then Karim Minati would be roasting TikTokers, right? So we would have never thought about that in 90s. So that's the power of internet, right? And we are at that stage in the blockchain world as of now, right? So yeah, so the how internet got like how internet's evolution happened, right? So internet was all about sharing information, right? So when we say that sharing information, right, it evolved into like from starting, let's say, this simple static web pages, right? It evolved into, let's say, sharing photos, sharing documents, sharing PDFs, right? PPT slides. Now we are doing live sessions, right? So that's how the internet has evolved over, let's say, all these years, right? Like in past almost 2 decades. And now we are able to see the what's the power of internet, right? How it has brought the whole world closer to each other, right? So yeah, this is see web 2.0, right? So after HTML5, earlier all the website were like a PHP, and then those web pages were static and served by let's say your backend, right? So then came HTML5 and the latest web technologies, right? You can build single page application. Your app websites are dynamic, right? It changes very fast. Though you can serve from server also, right? But now you can change everything using HTML and CSS, right, on the client side itself, right? But the thing is, the whole internet, right, it is kind of centralized as of now. So there are very few companies, right, which holds control over the whole internet, right? So you can see all these companies here, right? So there is nothing against them, right? But the thing is, all your data, or let's say all as you know, right, data is the new oil now. Even Facebook has invested in Geo. Why? Because Geo has a very big market in terms of as an internet provider, right? And you can imagine what kind of a data Geo would be having with this many Geo mobile connections, right, and free internet. And yeah, Facebook guys are smart. They have invested in Geo, right? So why it is for data, right? So as of now, you know, like all the services are free. Why? Because they are kind of mining the data, right, which they get it from our behavior, be it shopping pattern on the Amazon website, or be it our Instagram feed, right? What you like, what you don't like, which post you see, which post you scroll, right? So even they see the stories as well, right? That okay, did you just press next on the story, or did you watch full story, right? They have all the data and they're mining your data, right, at present. So it is centralized, right? They have too much control over, let's say, your data and your privacy, right? The downside of that is, let's say, if they don't control your data, right, then we'll have to pay for that. Simplest example is let's say our Google Photos, right? So what they do is, yeah, they allow you to upload unlimited number of photos, but then you don't have a control over those photos, right? Google, I think they use your photos to train their ML models, right, and deep learning models. So there's nothing against that. They are giving you free storage, right, free unlimited storage. But then if you compare, right, you get 2 TB storage of data at very cheap cost, right? Or even, let's say, you go for a cloud storage provider, you get it very cheap. But yeah, we choose that okay, I don't want to pay, and that's why they're leveraging your data, right? But then you should have option of doing all those things, right? So that's where we want to move, right, from the centralized world to decentralized world, where the power will be actually in the hand of users, a user, or in general the whole community, right? So that's what we wanted to do. So now let's talk about Bitcoin, right? Yes, if you have heard of banks, right? So why do we need banks? Anybody in the comment? Why do we need banks? Let's say if I want to pay 5 rupees to Ohm, right, or $5 to Ohm, or let's say anybody else, right? Let's say this guy called Ashish, right? Ashish Mehra. I wanted to pay to him, right? Then why do I have to go through bank? you can post your comments right here. I'll be waiting for your comments, right? If anybody wants to answer that. Okay. Yes, exactly. So I think Booksmart has told yes, exchange of money to pay somebody. We need bank to ensure that transactions are recorded. Yes. So the correct answer is that to ensure that transactions are recorded, right? Uh, Banking just allows person to make financial transaction. Yes, but why do we need bank? Transactions are managed. Yes, that is partially correct. Yeah. Point of trust in transaction. Very good. Yes. Sanatana, Dharmik, I don't know. Yeah. Then yeah, to do transaction and secure our finance. Okay, I'll come to that secure our finance point, right? Which is not entirely true. Yeah, mainly we need a bank the transact and to finance needs. Yes, but yeah, we have alternative for that for consistent exchange of money. Yes or no, right? Not completely correct. So see, why we need banks is banks acts as a trust, third party trust, right? So that's what it acts as a mediator. It brings trust in the, let's say, whatever transaction we are doing, right? So transaction is not just about money. So let's say if I'm sending goods worth of, let's say, one container from here to US, right? So what I need is I need some third party, some kind of mediator which kind of ensures, right, broker kind of person, which ensures that I deliver the good and then the other party gives me the payment. Correct. So that's why we need some kind of a intermediary, and that's how we've been doing things till now, right? So that's where the birth of Bitcoin had happened, right? That what if we have some kind of a payment network, right, which doesn't require any third party intermediary, right? We can do the point to point payments, right, without of any financial institution involvement. And then the other point is, yeah, so this whole transaction, right, those should be secured, right, and it should never be altered, right? And then there shouldn't be a double spending problem, right? So double spending problem is a very famous problem in let's say financial world, right? When we build this kind of a payment system, what happens is, let's say if I'm there are three persons, right? Let's say I'll just pick two names from our chatter, right? One is Yash, other guy is Santosh, right? So let's say I'm paying $10 to Yash. Correct. And then the transaction is recorded on the blockchain. Correct. Now let's say I can do and I can go and record the transaction that I have paid $10 to Santosh as well. Right. It's a digital record. There is nobody like stopping me from recording that kind of a transaction. So even though I had initially only $10, now I have recorded two transaction worth of $20. Correct. So that's the double spending problem, right? That's what we are here to kind of solve, right? That's what not we are here, but blockchain solves, right? And that's what Satoshi Nakamoto wrote about the whole payment system, right? Which solves this kind of a problem. Correct. Now let's say coming back to the security of the thing, right, with banks. I think somebody had mentioned that, yeah, to do transactions and secure our finance, right? Bank generally do not secure your finance up to the perception we have, right? So let's say until March 2020 end, right, bank was like, let's say if you have 1 crore rupees in your bank account, right? Just assume. I know it's a difficult times, but just assume. So let's say you have 1 crore rupees in your bank account, right? And then somebody happens, right? So bank is just liable to give you only 1 lakh rupees, right? Till I think before March 2020. and now I think it's up to 5 lakh rupees. So let's say you have 1 crore in a bank invest in some market, right? Or it gives to Vijay Mallya, or it gives to Nirav Modi, right? Anybody. And if they don't pay back, right, bank is liable to give you just 5 lakh rupees. That's it, nothing more than that, right? And this is by like RBI's law, right? So this is not me telling, it's there on the RBI's law that okay, a bank is not liable to pay more than that. So now you can assume, right, that your money is not that secure with the banks. Even for that matter, right, your lockers are not secured. You put your let's say valuables in the locker, right, like let's say gold jewelry, right, or any diamonds or any papers, right, property papers or anything. Now let's say somebody can come, right, in that those Hindi movie styles कि भाई हम बैंक लूटने आए हैं, देखिए इसमें पैसा तेरा नहीं है, जिसका भी है तेरे को क्या है तू दे दे, right? So so like they won't be able to secure your money. So if they lose your, let's say, gold jewelry or paper, right, you can't legally proceed against them, even though let's say they provide locker facility, right? So that's truth, I think. We can't change that. So banks are not that secure, right? That is why we need some kind of a secure platform which tells that okay, yeah, you have let's say you are holding this much amount of some asset, right? That asset could be Bitcoin, that asset could be anything else, it could be gold or anything, right? And then that platform itself acts as a source of truth. Now let's say when we talk about this kind of a platform, right, it has to be super robust, right? Nobody should be able to alter all the data, right? And it should be always up, and it should never be like doing preventing, it should be always preventing all kind of faulty transactions or any attempt to do any kind of malicious activity, right? It should be able to fend off all those kind of attacks, right? Then only this kind of system is trustable. Otherwise it's not trustworthy. So that's where whole Bitcoin, let's say, network or blockchain, right, comes into picture. Okay, so let's talk about blockchain, right? So blockchain is nothing like this kind of a simple book, right? So everybody would have seen, let's say, this kind of ledger, right, in the Karyana shop or anywhere, right? Probably near your house or somewhere. So yeah, blockchain is exactly like this, right? It's a simple ledger, right? It has all the entries, right? That okay, goods of this much was credited, then it got sold, so this much was debited, right? All those kind of things. I think I said the other ways. Yeah, so debited and credited. Correct. So that's what is your ledger, right? Now each of the page that you see, right, that works as a block, right? How why it works as a block is, in a page, right, you can always record, let's say, fixed number of transactions. Let's say if we are talking about this book, right, we can store only the transactions about I think 50 transactions. Correct. So yeah, ledger it is a ledger. So it is kind of a, let's say we can store only 50 transaction, but now this ledger has to be unique, right? It has to be unique, and has to be universal. Why it has to be universal? Because everybody should be knowing that how much, let's say, money other person has, or who has sent money to whom. So let's say all of us, right, I think I see some 20-30 people in the room, right? So let's say all of us has the copy of the same ledger. Now I make a payment to, let's say, one of the guy, right, Marcos, right? I send money to Marcos, but what I do is I kind of a broadcast that transaction to everybody. I tell everybody that I have sent $10 to Marcos. So now what everybody will do in their ledger is they'll reduce $10 from my account, and then they'll add kind of for $10 in a Marcos account, right? So now you go and check to, let's say, other guy, right? Ashish Pratap Singh, right? So if you just go and check his book, in his book also it will tell that okay, I had transferred $10 to Marcos. Or let's say if we go to Namarshi, right? So there also I think it tells that yeah, I had sent $10 to Marcos, right? So that's what it is, a universal ledger, right? That whenever a transaction happens, it is kind of broadcasted to everybody, and all the ledgers, right? All these kind of books are staying up to date at any given point of time, then only we can make sure that the all the data which has gone into the ledger, right, which is a correct and source of truth. If let's say I just keep it to myself, right, then I won't be able to ever prove that I had given this money to Marcos, right? So that's why we need a kind of a universal ledger, and it has to be like updated whenever a transaction happens or periodically, right? And then let's say if I try to, let's say I had sent $10 to Marcos, and now I don't have any money in my account, right? Now let's say again I broadcast a transaction saying that now I am transferring $20 to, let's say, Sejal, right? So now this transaction will go to each of you, right? And then you will go and check in your books that Jignesh had zero balance, right? How we can transfer $20 to Sejal? So you will say that, okay, no, this is a false transaction that you are trying to do, or a fraud transaction, right? For that matter. So not only you, everybody else also will be telling the same thing, that no, you can't transfer $20 to Sejal, you have zero balance in your account, right? So now that transaction won't be accepted, right? That transaction will fail, and I can't pay, let's say, $20 to Sejal, right? So that's how it works, right? You all, right, every each of you works as a node in this whole system, right? So we'll cover that part later, right? So that's how a whole let's say blockchain is built, right? We'll have different nodes which will have all the data, right, related to all the transactions that has happened in the network. And whenever somebody tries to do any kind of a transaction, right, at that time it will go and check whether the transaction is valid or not, whether it should happen or not. And then it also checks that how many people have kind of validated this transaction, right? If it reaches consensus, right, that yes, this transaction is valid, then only that transaction will be accepted. Correct? How it reaches consensus, right, what it does to make sure that there are no fraudulent activities, right? We'll be covering all this part as we progresses, right? So I think everybody would have got now a fair amount of idea of how, let's say, what kind of what is a blockchain and how does it look, correct, from all you have heard. So if you have any doubts, right, kind of you can always put it into the comment section, right? I'm kind of monitoring that, and I'll keep answering all your doubts, right? So please do not like shy away from posting your doubts, right? Because all these things are very like basic things, and these are these understanding, right? This will be very helpful when I'll be talking about some of the more advanced concepts of the blockchain, right? So yeah, please keep interacting, keep posting doubts, right? Yeah, so see what happens when you, let's say, send a Bitcoin, right? So blockchain is nothing but the some kind of a linked list, right? I'll be talking about that later, right? So see, whenever you send, let's say, Bitcoin from one person to another person, right? First is the address, right? You'll be getting this kind of a address. So in generally, like let's say if we are doing UPI payment, right? You will have some, let's say, your name, right? Jignesh at the rate okay ICICI, right? Or something of that kind of thing, right? So in blockchain world, right, especially let's say when we talk about Bitcoin blockchain, this is how your address looks like. So this address could be my address, right? So people who wants to send money to me, right, they'll have to enter this address. It will be very simple to send money, right? I think we have got question. uh, who checks the transactions? Yes, so there is a whole consensus algorithm, all the nodes in the let's say network, right, they check the transactions. How it checks, I'll be covering that soon, Aniket. Today is the day, right, we learn about all the basics of blockchain, right? So yeah, don't worry, like we'll be just covering all the concepts, right? So keep asking questions. Which is better, Hashgraph or blockchain? Hashgraph is a blockchain, I think, right? So there are different blockchain platform, and Hashgraph is also, I think, one of the blockchain platform, as far as I know. Yeah. Hail Hydra. Okay, Hail Hydra. Do you have access to the balance of all nodes? Yes, you do have access to the balance of all nodes. Books make. Is it true that there must max number of people, otherwise price will become too low? Okay, no. So we won't be talking about price much, but just to answer your question, right? The price of any coin, right? Any, let's say, Bitcoin or any other network or any commodity, right? It inherently comes from how many people are using that. If nobody is using gold, right, the worth of gold will be zero. If nobody is using, let's say, Bitcoin, the worth of Bitcoin will be zero. Versus if many people find that yes, it is very useful, right, then the price will rise. Again, that price will be controlled by demand and supply. Whatever we have seen in the oil market, right, the last whatever crash we have seen, there was too much supply, and then demand was almost like very low, right, than your regular days, because of lockdown and the whole COVID-19 situation, right? So supply was too much, and then demand was too low, so that's why the prices crashed. Correct, nobody had space to store oil, all of the tanks were full, right? So yeah, again, the price is vary due to many factors, right? So but it's not like that there be must max number of per people, right? It is not like that, right? Then, as being a miner, how can a miner go ahead to verify the transaction is valid on the blockchain ledger? Yes, so miner just have to run. Miners are nothing but the person, right, who will be running some kind of piece of software on their machines. Now this piece of software is written in a such a manner, right, that it verifies, it has inherent logic to verify the transaction, right? And the same logic will be running across all the different miners, right? So what is this logic and how it is written, we'll be covering soon. But yeah, I like the way you guys are asking questions, right? You guys are asking correct questions, and yeah, we are in right direction. Perfect. Where is blockchain data stored? Blockchain data is stored on the mining nodes, right? So when I say mining nodes, it's just a fancy word, but it's a basically a computer server, right? It could be your laptop, it could be your EC2 instance, it could be Azure instance, right? Any machine, it could be your desktop, right? So there it has to have some kind of a disk space to store the data, and that's where all the data is stored. Okay, where is the blockchain data stored? Okay, we have covered. Very interesting. Okay, cool. Thank you, Binu Kumari. Okay, what basic subject knowledge needed to know blockchain? Yes, so basic subject knowledge, right? So you need to know, let's say, at least one of the programming language, right? And then you should be knowing a little bit about how, let's say, any software system works, right? Then how a peer-to-peer network works, right? And then I think probably you should have just sense of a general any software system, right, how communication happens, right, over the web. I think that should be more than sufficient to understand blockchain, right? Yeah, there are so many concepts, right, like cryptography, then p2p protocols, correct, then your db knowledge, then your distributed dbs, right, then system about like knowledge about distributed systems, right? All those things are there, but whatever I mentioned right earlier, those are very basic things. If you know that, I'll be more than happy to explain you the rest of the concepts, right? Yeah. So moving forward, right, this is how any of the address on the Bitcoin network, right, looks like. So let's say if I want to send money to anyone, right, all I have to do is just enter that address. Correct. So from my Bitcoin wallet, right, that could be address. I want to send somebody, right, whose address is this. So I'll be just sending, adding this address. It just looks like your Paytm, Phone Pay, or Amazon Pay, right? And then you just put amounts and everything, and then you press send, right? So you'll be paying some fees, right? Here it shows that 2114, right? I know that for 500 rupees, 214 rupees is too much fee, but we'll be talking about that also. How does can we develop DApps using Tezos. Yes, you can build DApp using Tezos. We have boilerplate code as well, right, to kind of very quickly develop your DApps, right. I'll be covering that in tomorrow's session, right. Today it's all about blockchain, basics of blockchain, Bitcoin network, Ethereum, and Tezos, right, concepts. How does synchronization work between nodes for a transaction? Yes, for that, if you have knowledge of, let's say, P2P protocols, right, what happens is all these nodes in the blockchain, right, they keep talking to each other, right, continuously. So they'll be passing the data like to and for, right, across the whole network, and that's how the whole blockchain is synchronized, right. Okay, so coming back to the Bitcoin part, right? So yeah, it is as simple as this. You just enter your address, press send, and you'll be kind of transferring money to other people. Yeah, but then what happens, right? What is it like mining? Correct. So let's talk, I think, a little bit about mining and blocks and everything, right? But before, let's say, jumping to mining, I want to explain you some of the other terms, right. So let's go back to again very basic thing, right. If you have known, you I believe you all of you are from computer science background, right. So you would be knowing a little bit about, let's say, linked list. Correct. So blockchain is nothing but a simple kind of a linked list. Correct. This is how your blockchain looks like. Any blockchain. Correct. So what you have generally is there will be always a first block, right, which will be a first node of a linked list. You can see here on the left side. Uh, First block of any blockchain is called Genesis block, right. So it will be the kind of starting block of the any blockchain. Now each of the block, right, they will have some kind of a header and some kind of transactions. Header, what is in the header? Header will have, let's say, all the metadata, like okay, what's the hash of a previous block, right, how many transactions are in the block, what is the block number, right, then how many blocks or how many transactions per block it should be there, and then at what time the block should be created, and so many other things, right. We won't go into the detail of what are those exact metadatas, but yeah, there will be some metadata which is called header, right, and then you will have set of transactions. So when I say transactions, right, let me go back to the example of our this by khata, right. Here, if each page, right, each page is a one block, right, and then header would be the page number and the other data, right, that how many, let's say, lines are there in the page, and on which date, let's say, this we started writing into this page, right, and then on which date this page got filled up, right. All those kind of data, we can call it as a header data, right. So that's how your blockchain looks like in general, right. So there will be a genesis block, then it will have some kind of a number of transactions. Now how do we create blocks, right. So blocks are nothing but a number of transactions, right. When we put together number of transaction, it creates a block, right. So here you can decide that, okay, I put 1,000 transactions together and I will call it a block. So we kind of calculate that, okay, first, second, third, fourth, I have 1,000 transactions, I go and create a block, I put a header, right, and I will treat it as a single block, and I will create a hash out of that block. Correct. That hash will be unique for that block. How it will be unique, will be knowing in the later part of the same our session, right, that how we make sure that this hash is unique. Then we come from 1,000 first transaction, right, till 2,000th transaction. What we do is we create another block, right. So we wait for next 1,000 transactions, and then we create a next block, right. And then in header, right, we put all the information that, okay, the previous blocks hash was this, This is the current block's hash, and that's it. Then for next 1,000 transactions, we create third block. All these blocks are kind of linked to each other, right? And that's how the whole blockchain is formed. Correct. So yeah, and then what happens is whatever previous hash of any block, right, that will be used to create the hash of a next block as well. So when we if you know the basic of, let's say, any cryptography, right, or hashing algorithm, if you change the data, right, of which you are creating a hash, if you change the data, your hash will change. Okay, so this is very basic simple concept, right? Let's say uh, I have some kind of okay, I'll be just sharing my screen. I hope you guys are able to see some data, some text file in my this one screen, right? So now let's say if I change any line in this file, right? So let's say first I'm creating a hash for all this data, right? And that hash would be like something of C645, right? So this is the hash that I have created, okay, for this data. Now let's say if I change this value, right, from cart1 to cart2, then this hash will change completely, right? It could be something like this. So yeah, that's how hashing works. Okay, so going back to again our linked list example, right? We kind of create a hash for each of the block like that, and that same hash is used to create a hash of another block. So let's say if you change any data in the previous block, the hash will change, and that's how we kind of make sure that no data has been altered, right? So just think about that, right? Post questions. I have got, I think, many questions here, right? So I'll just take a while and answer some of them, right? Till kind of ponder upon this. And if you have any question, feel free to ask. This is again a very important concept, right? That how a block is created and how hash is used to kind of create the next block's hash. I'm interested to run a node for Tezos as I have 8,000 Tezos. Are you going to cover running a node for Tezos? Yes, we'll talk briefly about that, Yash, towards the end of today's session, right? Or when I'll be explaining how Tezos baking and everything works, right? So I'll explain that. Is there different types of blockchain? Yes, there are different type of blockchains. So there are the blockchain. How different blockchain differs from each other is how they are doing things, right? And then how secure they are. So when I say how they are doing things is there are concept of your consensus algorithm. So blockchain could be using proof of work algorithm, then they could be using proof of stake, they could be using delegated proof of stake, which is called depose. Then you can using liquid proof of stake, which is alpose, right? And then you could be using proof of something, like, so it could be proof of elapsed time or proof of some other thing, right? You can use anything. So again, your consensus algorithm could differ. Then how you're doing things, right? How you're writing smart contracts, right? Or how secure are your smart contracts, right? So by all these parameters, your blockchain differs from each other. Yeah. Difference between node and miners. Yeah, so nodes are a set of like it's kind of a web server, right? You can uh, compare it to your normal web server, right? If you have ran a simple REST server, right, for any of your to do application, right? If you have written in Node.js, Golang, Python, right? So you can compare that code, right, your web server code with a Node's code. And the guy who runs this node, right, basically he's called miner. Okay, then in the English we can alter data, but in blockchain, I think yes, in blockchain it is not possible to alter the data, because whenever you alter any kind of a data, right, the hash will change, and then the hash of the next block also will change, and the hash of next block also will change. So by that, like, everybody will know that, when I say everybody, all other nodes will come to know that no, this is not the correct hash, right, that whatever I have. So it is basically not possible to change that data in the blockchain, right? That's the again that's how blockchain kind of takes care of your security purpose, right? Correct. I think Prajwal has answered it beautifully. So the second block contain first block hash plus next 1,000 transaction. Yes, exactly, Sanatan Dharmik. Yeah, cool. Oh, okay. Sorry, Aniket. I think I didn't zoom it properly, but I'll have some example, right, which you can try it on your system only, changing the data and creating hash, right? I'll be posting it here if I'm allowed to. Okay, how can we solve scalability issues, like some time BTC confirmation more than 10 hours to 24 hours? Is there any view? Yes, so there are lighting. So Bitcoin already has a lightning network, right? Which kind of solves this problem of transactions being slow. Then there are concept of side chains, right, in Ethereum. So which kind of again batches your transactions, right, and pushes it to the mainnet altogether, right? So there are different, let's say, layer one solutions, layer two solutions, right, which kind of enables users, right, to kind of do the transactions in a very fast manner. One thing that everybody has to know is in blockchain, right, your throughput, right, throughput is transactions per second, which will be low compared to your traditional system. Why? Because here we have to make sure that whatever goes into the blockchain, right, it's verified and it's not a wrong information, right? And to make sure that it's verified, we have to talk to many nodes in the network, right? So that will bring down, let's say, your transactions per second, right? But it then increases the security of your network. So that's the trade-off between your normal distributed let's say system or normal distributed network versus a blockchain network, right? Okay, what is minimum size of a block? Okay, maximum size of a block, right? So again, it depends on how that user has any particular user, right, who has written the blockchain code he has designed. So sometimes, let's say, I can say that okay, I will store only 1,000 transactions. Now when I say transactions, right, transaction can have a lot more data, right? It's not just about that address A has sent data to address B. It could be storing your Aadhaar card information as well, right? So in that case, what happens is, your for each transaction, right, payload increases. So now let's say for 1,000 transactions, right, the payload could be, let's say, even 10 MB also, correct? But then what I can decide is that my block would be of, let's say, 1 MB. So what I do is, what when I say I do is, basically each node, what they'll do is, they'll uh, kind of slice the transactions and put together in a batch, which are like no more than 1 MB in the size, actual size of data, right? So when I say any text file, it will have some size, right? It could be few kbs, or it could be 1 KB as well, right? So if I put, let's say, 1,000 transactions of a 1 KB each, right, so that could be 1 MB, right? But let's say if I have a transaction of worth 2 KB, then I can put only 500 transactions, like that. So it could be again decided by the community or by the platform, right, that what should be the block size. We'll be talking more about that as well, right? Correct. Are we not trusting the nodes? How does trusting bank problem get solved? Yes, I'll tell you that in a bit. I'll tell you that in a bit. Correct. So for that, right, the same thing. This is the first concept, that we can't change any data, right? Whenever we change the data, the hash changes. So basically, all the nodes, right, they will have different data. So this is kind of similar to anybody just going to bank server and changing the data. What will happen is, in case of bank, right, it's a centralized. So somebody from the bank system, they can just log into the DB and then they'll altering the transaction, right? So then you don't have any proof. But here in blockchain, you can't do that. You will have altered data only on one node, but then how you verify? When you try to verify with other nodes, right, all the other nodes will tell that, okay, no, this is not the hash that I have, my hash is different than your hash. So then the consensus comes into picture, right, that whatever majority nodes are saying that, right, which is right, that that will take precedence as a kind of source of truth. So in that case, nobody will trust, let's say, altered transactions on your node, right? So that's how your trust problem is kind of solved using that. Yes, Hail Hydra, right? System fails when more than 50% of users are not trustworthy, which is perfectly correct answer on that, right? It is called 51% attack. How it happens, right? And why it can't happen on blockchain, Bitcoin network. I'll tell about that. Why do we store data in blockchain? As we know about hashing, we can also store hashes of those data into blockchain and store data in centralized database. By this, data security and integrity. Centralized database are not that secure. Any user, right, just think about that, like Amazon Pay or Paytm, right? You have 1,000 rupees in your bank account on Paytm wallet or Amazon Pay, right? So engineer who has access to your production DB, he can just go and change that amount, and nobody will be kind of you can't contest that. They'll say that, okay, no, this is the data, right, and you'll have to accept that. Versus you have some kind of a public network, right, where kind of changing the data is not possibility. Why? Because all the changes are public. So let's say if somebody has changed data from 1,000 rupees to 10 rupees, that data is also public and on the network, so that you can point to the transactions. See, with this transaction, right, this particular transaction on this date with this timestamp, right, somebody had done the change. Now who is somebody? That is also recorded on the blockchain, that this particular user had pushed this kind of a transaction which has reduced the balance on my account. Correct. So that's why it's not that straightforward to, let's say, storing the hash of the data on the centralized server, right? That's where we want to remove the trust, because when we say we are going to remove the trust, right, we are saying that, okay, hey, hi guys, I think, yeah, I had a internet connection issue. Sorry about that. So yeah, we were talking about removing the trust part, right, from centralized system. So when I say that we remove the trust from any third party, right, basically we are putting a trust in our system, digital system, or on the code, right? So if anybody can alter the code, right, in a centralized database, basically you have changed the data. Does every node has a full copy of blockchain from Genesis block? Yes. Everybody has the full copy since the Genesis block, right? I know that. Then the next question that could come up is, how can we store this much of data, right? But just to counter that, right, you can get 2 TB of a hard disk at 3,000 rupees, right? And that is a retail. So if you go and try to buy server of petabytes, right, it would be like costing you per TB much lesser. Correct. Yeah, there was a connection problem and I lost you guys. Like, yeah, sorry. Okay. How we can check hashes of those data with blockchain store hash? Correct, by changing the data in centralized, they also changes the hash. So yeah, no, it's not that simple, right? Then everybody, then see, essentially we are doing the same thing. I know what you are trying to say in a centralized database, right? but then we want to remove that kind of a dependency, right? That I have to send kind of go and trust a simple server. I can go and alter all the data of all the server, right? So let's say when we are talking about centralized server, this is a very good point that Rishabh is making, right? Uh, yeah, what if we change all the hashes, right? So that's how 51% attack happens, right? Whoever gets more power, right, what they do is they start changing the hash of each block from the block they want to alter, right? So let's say there are 1,000 blocks in the blockchain, and let's say at 500th block, right, somebody is altering. So from that block onwards, you have to go and change the hash for each of the blocks, right? Then only you can prove that all these are valid things. Now how we are slowing down this process, I'll be covering in the mining, right? That from 500 block onwards, let's say a user goes and changes hash for each of the block, right, because he has altered here. How to prevent that, we'll be covering in the mining. But yeah, it is a very valid point. And yeah, this is the reason why we can't trust let's say centralized databases, right? So okay, let's talk about then mining, right? So mining is nothing but a kind of a process in which, right, we solve some kind of a mathematical puzzle, right? So how do we do that? So it's nothing. It's kind of a process to slow down the creation of the blocks, right? Why do we want to slow down the creation of blocks? Is to prevent the same thing that we had just discussed, right? That anybody can come and change those transactions very fast with enough computation power. So what we do is with each of the block, right, we attach a nonce. Nonce is nothing but some kind of a unique identifier for that block. And how do we, let's say, kind of create that nonce is using a proof of work. So proof of work is some kind of a mathematical puzzle or a cryptographic algorithm, right? Just to kind of keep it very simple, right? It's some kind of a cryptographical puzzle which you have to solve. And how you can solve is you have to put your computation power for that. When I say computation power, you need to provide it CPUs. Correct. So you have to provide that, and then only you can kind of create that nonce, and that nonce will be kind of your proof of work. So when I say proof of work, is the work you have done is you have done some computation. When I say you, it's your computer or your node which has done the computation, right? And you are kind of attaching, getting the proof for that work. It's kind of a receipt that you have done this much of work, and then you attach that receipt with your block, and now this block will be published to all the nodes in the network. Correct. So now every time whenever anybody wants to publish a block, right, they have to kind of get all the transactions, right, which can fit into one block. It could be 1 MB block, then they have to get the transactions of worth 1 MB. It could be, let's say, 1,000 transactions. In that case, they have to get 1,000 transactions. So for that much of period, they have to wait. Correct. Once they get those many number of transactions, they form a block. They do this proof of work for this let's say block, right, all the computation. With that they get a nonce, then they go and send this block to everybody, and all the nodes will be doing this the same thing. Whoever does the fast, right, that node's block kind of gets accepted. Correct. So that's the very, like, in a simple terms, that's the process of mining. If we go and talk about each of the parameters, right, how actual mining works, right, there are different concepts, but we won't be going, let's say, much deeper into that, right? For that I need some kind of a, let's say, whiteboarding, and then we would require more duration of the session, right, to do that. So I'll be just touching that little part only on proof of work part. Okay. Yeah. So that's about the let's say mining and proof of work. So what we do with this proof of work is generally in let's say when we talk about Bitcoin blockchain, right? It is intelligent enough so that let's say if somebody is kind of the whole network, right, all together, if they're mining the blocks too quickly, right, then it will increase the difficulty of this proof of work that you are doing. Correct. So now what that will translate into, that to get the knowns for each of the block, right, you will have to spend more computation power. Correct. So just to give you example, right, when this, let's say, Bitcoin network started like in very early time of the Bitcoin network, right, in 2011 or so, we were able to mine, let's say, Bitcoin using our normal CPUs, right, with a 4 core machine, right, our laptop and all. We were able to mine, but as the time has progressed, right, the difficulty has increased to such a manner that now people use kind of mining farms, right. So let me just uh, show you the one of the such probably screenshot of a mining farm, right, how it looks like. Let me stop sharing and then start yeah, you can see, right, sorry for the slow internet, right. But you can see how many server racks are there, right. These are mining farms. So this much power requires, right, to kind of mine a single Bitcoin, right. So when I say a mine, right, what happens is, now user, right, any user who is kind of spending this much effort, right, electricity and all, to make sure that all the transaction which goes in the network, right, those are correct and nobody is kind of doing any fraudulent activities on the network, right. So they kind of provide this computation power, and for that what they get bitcoins, right. How the network gives the bitcoins to them as a kind of a reward for all the work they have done on the network, right. That's how bitcoin is generated. Unlike our traditional money, right, how our traditional monies gets printed is, government decides that, okay, I have a gold worth of 1 ton, right. So then I can, let's say, produce 1 million currency notes, right, something of that sort, or something, some kind of a, let's say, uh, what we say, other exchange of medium, right, it is used, gold and then some foreign exchange reserve, right, all those things are used to kind of print money. Versus here, the guy who is putting all his efforts, right, the mining effort, for that he gets like kind of rewarded with a bitcoin. And that's how like a bitcoin is generated, right, with all the mining that happens, right. So mining is nothing but a simple process, right. You run a web server, you provide electricity to that, basically a computation power, and for all the work and the, let's say, electricity that you have put into the network, right, you get rewarded with the bitcoin. Now you can go and sell this bitcoin to some exchange, and then you can buy something or anything, right, basically. Cool. So as of now, I think what happens is, after so there are, okay, there are only 21 millions Bitcoin, right, and more than 18 million Bitcoins have already been mined. So if you hold, let's say, even one Bitcoin, right, so you can think, right, what's the population in the current world, and then if you have one full Bitcoin, you will be amongst under top 1% in the world, right. So because we have only 21 million bitcoins, and every 4 years, right, approximately, the number of bitcoins which are mined in a block, right, that gets half. So just to like give you example, right, the next halving, right, that is going to happen on May 12th. It is now less than 500 block away, right. So in next, let's say, 450 blocks, a halving will happen. So as of now, I think mining reward is 25 or 12.5, and then that will be kind of cut down to either 12.5 or let's say half of 12.5, that is 6.25, right? So and that's how like it will go half half half. And when all the bitcoins are mined, right, then there wouldn't be any much, let's say, reward left for miners through mining. But then they get other rewards, which is a transaction fees, right? Whatever happens on the network. So whenever a guy is sending money from one person to another person, all those transaction fees, right, those also are part of the reward for any blocks. So whoever mines the block successfully, right, they get a mining reward plus all the transaction fees incurred in that block. So that's the whole let's say uh, all about mining, right? I know I've been very abstract and very high level, right? But I think you might have got the idea, right? Please feel free to post your questions, right? All the details related to mining, right? Probably I can provide you some resources to learn, or you can head over to our Tezos India Foundation channel, right? There you can post questions, and I'll be more than happy to answer you, right? Or in a one-to-one session, right? I'll be able to explain you. With limited time, I'm just kind of skipping over the much details of the mining. So as I had previously said, right, this is what any block contains. It has a hash of like previous block, then some data are nothing but your transaction. Nonce is your proof of work. You have done some work, you have given some CPU power. With that you get a hash, right? So that is your nonce. Basically, when I say hash, basically it's a number. Nonce is a number. And then this hash is a kind of like a cumulative hash of all these things: previous hash, data, and nonce. So if any of these thing changes, right, this hash will change. So let's say if we go to a blockchain demo URL, right, I'll be posting this in our channel as well. Chatter, I'm not sure if I'm able to put. I'll just put it in this private channel. If any of the organizer or anybody can pick up, right, you can just go and post it there for our users. Okay, I hope you all are able to see my screen. I know it's mirrored. So as you can see here, right, see, this is the first block, right? We have a data, welcome to the blockchain demo 2.0. And then it has generated a hash called this, correct? Then let's say I add a new data, that this is GDG Gwalior session, right? So see, it has added a new block, right? Previous hash is this, which you know there is it's on upper side. Okay, I've zoomed it. Okay, and then I can again add some new data. Okay, so now this is a new block. So now as of now we have first block, which is a genesis block. Welcome to blockchain demo 2.0 data. It contains this data. Then next block is this is GDG Gwalior session. Third is I'm Jignesh, right? Now what happens? Let's say if I try to change this data, right, instead of this is GDG Gwalior session, I'll say this is GDG Gwalior workshop. Now you can see, right, the hash has changed. So that means the next block, right, that is also not valid because the hash has changed. So like this, right, let's say if you have 1,000 block, all the hashes will change. And then you know that this is not the correct data. Your data has been tampered with, right? So when you kind of get the final hash, it will be different. So this happens on the, let's say, all of the nodes, right? So the node will accept only data, right, which has the correct hash and the data. Otherwise they won't accept. And then there are some logic, right, to kind of punish the nodes which are not kind of providing the valid data. Correct. So I hope, I think, all of you, right, have tried the demo. I'll just wait for you guys, right? Yeah, yes. Just to answer your question, right? I think I had explained that whenever, let's say, all 20, this is not a silly question, right? This is a very valid question. When all 21 million bitcoins have been mined, right? What happens is, it's not just that these bitcoins are like whatever bitcoins that network generate, right? Those are the part of the reward. Uh, just a minute. Why is it not sharing? Those are not just part of a reward, right? The transactions, right? So each of the transaction will have some fees. Why it will have some fees is nothing comes for free, right? When we are talking about decentralization, right? We talked about Google Photos, right? To store photos, we need to pay some fees. Then only we have complete right on our photos, right? Similarly, here also, whenever we want to make a payment, we have to pay some fee to the network. Why? Because network is making sure that my payment gets successful, plus nobody is able to kind of hack into or basically doing any fraudulent activities on network, right? So these are the nodes and miners which are making sure that our network is secure, right? And if our network is not secure, nobody will be using it, and then there's no value of the currency, right? Bitcoin or anything. So we have to pay this transaction fee. So let's say there are 1,000 transactions, so all the transactions free for that particular block, right? That also goes to the miner, which is like successfully mining a block, right? So let's say there are 1,000 different miners, and miner number 11, he successfully mines the block, so he gets the bitcoin mined by the network plus all the transaction fees, right? So these transaction fees are also will be in bitcoin uh, only, right? So they'll be also getting this fees. So when all 21 million bitcoins are mined, all they get is a transaction fees. Correct. And they'll be doing mining only if this is working out for them. So let's say, just to give an idea, right, by chance if that happens, that after all 21 million bitcoins have been mined, the transaction fees that these people are getting, right, miners, is very low, than the cost of the running mining setup, right? Then they won't be mining, and then all the miners will drop from the network, right? So then nobody would be using the transaction, and the whole network will loses its value, right? So for in that interest, by that time, everybody will have to make sure that the network is like self sufficient, right? And without any, let's say, inherent mined bitcoin, right? Miners are getting enough profits, right? Or miners will take only like more than some particular x amount of a transaction fees. But yeah, it is a good question. Yeah, Prajwal, I think we'll be covering that part in tomorrow's this one. That what are some hackathon winning ideas based on blockchain, right? We'll cover that. There are so many things that you can do with the blockchain. How many confirmations are required for deposits? See, confirmations are again, it depends from platform to platform. It's like see, generally you can think that whenever a block is like mined, right, you can very well say that, okay, yeah, this is correct data, right? And you can accept this as a source of truth. But generally what happens is, just to make sure that uh, nobody does the kind of double spending, right? Or nobody tries to do any fraudulent activities, what generally people do is they wait till like 10 blocks or 12 blocks, right? Again, depends on the network they are using to confirm. So what they do is, after 12 blocks, it becomes difficult to kind of revert all the 12 transactions, right, for anyone. So that's why they then generally wait for some confirmation after any transaction. So it depends on platform to platform. So on Ethereum network, it could be that one of the exchange, they use 12 confirmation for any transaction, whereas other exchange, right, they could be using three confirmation from network. Yeah. Okay, so I think we are very well clear on mining and how, let's say, blocks are created and how blockchain is formed, right? So yeah, like just to conclude, right, a blockchain is a digital record of transactions, right, where blocks containing the transaction data, which are linked together, right, in a single list, as we have seen, right, and called a chain, and that's how the whole chain is formed, and that is why the name blockchain. It's a chain of blocks, right? And then when we talked about Bitcoin network, right, it just stores the data related to currency, right, or the amounts. But then this is a blockchain 1.0, right? Whatever internet we have seen in 90s, right, it was very simple, very primitive. So now people have like made improvements in that, right? The way we had web 2.0, html, css, in a blockchain world we have the blockchain 2.0, 3.0, right, with smart contracts and different consensus algorithm, right? So we'll be talking about that. Correct. So I want you to kind of go over, let's say, this video as well, right, which kind of briefly explains about all these things that we have discussed, right? Let me know if somebody can post this comment on our public forum, right? I have posted two comments in a private chat. If any of the organizers are around, right, please somebody pick this up and post it on a comment thread. The first link is the blockchain demo, right, that I showed. By entering different datas we can generate a block, and then whenever you change any data, your hash changes. And the second comment is about the a video, right, again a YouTube video that we generally show it in our live sessions, right, when we go to colleges and all. So yeah, I think it will be a little nice break of 5 minutes for me, right? And yeah, you guys also can kind of take a look at whatever you have discussed, right? And meanwhile, yeah, keep posting questions. I'll be taking your questions, right? We are getting some nice questions, right? I just want to say that yeah, all your questions are in the right direction, and those are the kind of questions I expect, right? So yeah, thinking process is correct and in the right direction. Please ask many questions, right? What will be the future of Bitcoin? What kind of a future that you are telling? If it is about decentralization, right, I see like there is a lot of needs of decentralization. Why? Because we have seen the examples, right, with the centralization what could happen. A single, let's say, bank could give loans to a single person with bypassing all the, let's say, regulatories, norms, right? So when I say single bank is like single chain of like two or three people, right, they do all the things, right, and then everybody else has to suffer. So on a decentralized platform, right, chances of this kind of things becomes very low, right? Why? Because you need so many bad actors in the system to do that, and once you do that your system doesn't hold any value. Bitcoin is illegal in some countries. How will that impact? Bitcoin is, I think, not illegal in the many countries, right? Even like if you see, right, most of the countries have like uh, all the major countries like US, China. It's not illegal. Everybody is able to trade the Bitcoin, right? Only restriction they have is that they have to follow the IRS rules, right? So in US, IRS is basically income tax department, right? So you have to follow that whenever you do trading, right? Any profit you make, you have to kind of file a tax, right? A return for that, and you have to give tax for the profits that you have earned, right? So they are regulating the Bitcoin, right? So it's not illegal in the measure of the countries, right? For that matter, I think in Venezuela, right, where inflation was too much, I think now like majority of the public, right, they kind of trust Bitcoin, right? And then they use Bitcoin for their day-to-day purchases and all. In Europe and in many of the Americas, this one, right? Let's say eateries and all, right? McD and all those kind of things, Burger Kings and all, they accept payments via Bitcoin, right? So I think that's how it is. So the famous Bitcoin pizza, right? A guy, I think, not, I don't remember exact the year, but he had given 10,000 Bitcoins to buy a pizza, a large pizza, 10,000 Bitcoins. Today, the price of a Bitcoin is $10,000. So you can do 10,000 into 10,000 into 72, that many INR. So you can get the idea. Right. So yes, most of the countries are regulating that. In India, Bitcoin was not illegal, right? What RBI had said is the, let's say, RBI controlled entities, right, which are banks and NBFCs, they can't engage into the companies, right, or organization which handles cryptocurrency. So basically, those are exchanges. So you can't link your, let's say, bank accounts with those exchanges and transfer money to exchange. That's what RBI had said no, right? But then you what they like exchanges came up with is a peer to peer. So you can always transfer Bitcoin to someone, and then they will transfer INR to you, right? That was not banned, right, by any law. And then Supreme Court, so the case was going on since I think 2018, right? And then Supreme Court said that yeah, this is unconstitutional, right? You can't ban things like that just that you don't know. Because so if you have like there are Twitter threads, right, about this whole proceedings. You should be going and reading about that, being in the blockchain field, right? It's very interesting thread. Some of the arguments, right, they have made, you will know that how our system works, right? They, in some of the cases, right, they had quoted reports way back in 2016 and 17 from some countries, and now those countries have already amended their rules, right, or whatever reports, and now they made it a kind of they are regulating Bitcoins. And our these people, right, who are opposing let's say Bitcoin, right, they were quoting those old versions of the bans, right, in our Supreme Court in like last year 2019, right? So but yeah, the good part is you can go and buy Bitcoins on an exchange, right, just like this. You can buy via UPI. As of now, only within 5 minutes you can buy. You just have to make your account, transfer money to exchange, buy Bitcoin or any other cryptocurrency, right? Yeah, some practical sessions will also be there, yeah, but first we have to clear all the basics, right? That's why practical session will be tomorrow. I know, like you would be waiting for today also, but without covering basics, it's not right to do some practical sessions. Okay. Can blockchain technology be hacked? To be frank, yes, it can be hacked. For that matter, any technology can be hacked. It's all about how you are making it secure. So if you say that can Bitcoin network be hacked, I would say chances are there, but very slim, like 0.00001% that it can be hacked. Okay. Why? Because it's not just about technology. There is a whole kind of socio-economy aspect also to that. So that's why it's very difficult to kind of hack or do 51% attack on a Bitcoin network, right? It won't work out well for anybody, even for the attacker himself, right, or herself. Yeah. So yeah, so when we talked about, let's say, Bitcoin, right, it was just about the currency transfer. But then what if we, let's say, want to kind of store the data, right, in a secure manner? When I say data, it could be your other data, right, or let's say, for that matter, as of now we are hearing that this Arogya Setu app, right, all the data is going to the government server, and then some of the intellectuals are claiming that the data privacy is not there and all those things, right? Even though I kind of have a strong belief in the system, right, that our systems are very much robust, right? I know what was there in the Aadhaar, right? But now our system have improved the UPI, right? One of the best payment network in the world, right? So I do believe in our current system, right? But let's say if you want to secure all this data, right? Why you want to secure and make it public is to make sure that public is aware of that. As of now, you can't go and see the data on the server, right? Or you can kind of access the data in a secure manner, and you don't have any proof, right? You just have to trust the government that they're doing the right thing. But we want to remove that trust, right? So that's where blockchain can come into picture, and you can store all the Aragyu data on the public blockchain in a secure manner. So data is in the public, but you can't kind of crack it. So all those kind of things are possible with the blockchain. So that's where comes blockchain 2.0, right? With Ethereum network, right? Ethereum and similar platforms, right? Those are called blockchain 2.0. What new they have done is they have brought the concept of smart contracts. Smart contracts are very powerful things, right? What you can do with smart contract, you can kind of write some code, some business logic in the smart contract, right? And by that way you'll be able to store any data on the blockchain, right? So it gives you kind of an interface to store any data. So in Bitcoin network, all you can do is just give an address and send some money. Here what you can do is you can give an address, then you can give a payload as well, that I want to store, let's say, this data, this data, this data. So it's not just about storing, it can do the conditional as well, right? That you just go and push the code. You can push a method on the blockchain and it will do all the verification, that okay, only if the balance, right, if it is more than $10, then only store this information. Only if this person, right, particular person, let's say I am the administrator, so only if administrator is doing this transaction, then only push the information, otherwise don't change the information. So all these kind of things you can do with the smart contracts. Smart contracts are just piece of a code which is stored on the each of the node in the network, right? And anybody, it's a public, again, on public network, smart contract addresses are public. So you can just call that smart contract via that public address, right? And then you can kind of call any piece of logic with that. So that's about blockchain 2.0. And then comes the blockchain 3.0, which is Tezos and the other networks, right? Tezos has a self-amending ledger, right? I will talk about that soon, right? So let me just switch it. Yeah, so see, Tezos, right? So let's talk about something about Tezos. So Tezos is has a self-amending nature in the blockchain. How? So now let's say whenever you kind of run a node or anything, right? The code that which you are running, right? All the configurations are pretty much hard coded, right? Because once, let's say, you have 1,000 of nodes, now to update all the nodes, right, what you have to do is you have to kind of inform all 1,000 people, right? You have to kind of bring them in on a single platform together, that okay, now we want to improve our nodes with this patch, this security patch, or this new set of features. So what you have to do is you have to kind of bring all of them together on a single forum. You have to present to them and you have to convince them that yeah, this is for all of like our own good, that we have to do this update. Once that happens, we have to test that update and then have to push that update to a public on the public nodes, right? So this becomes very difficult process. In that, what happens is sometimes some of the people can agree, some of the people don't agree. Let's say out of 1,000 node 1,000 people, 900 agrees, 100 says no, right? In that case, what happens is the 900 will be using the updated codes, the 100 will be using the old code, right? And then there will be two version of the same blockchain running, So this is called hard forking, right, in terms of blockchain. So now these hard forks are very common, right? So there was a time when a hack had happened on the Ethereum network, right? So what had happened is, I think there was a flaw in a smart contract, right? And somebody had stole, I think, millions of USD worth of money, right, from the smart contract. And what they did is they kind of rolled back, right? But then some of the community member didn't agree with this, right? So now there are two versions of the same blockchain. One is called Ethereum, which is updated blockchain on which they had rolled the transactions, right? Which is not pretty right, but at that time, if wouldn't have been done right, the community may not have survived, right? So that's whole different discussion. And then the original blockchain, right? It is called as Ethereum Classic. So if you go to CoinMarketCap or any other cryptocurrency website, right, you can see Ethereum Classic and Ethereum. So Ethereum is the blockchain where this hack, right, where the transfer of, let's say, million USD was done from one account to another account, it was reverted. So that is called as Ethereum network, which is a current Ethereum network. And the old network where it was as it is, that this guy had transferred this many millions of USD to, let's say, person B, and that is called as a Ethereum Classic. So those hard forks are kind of pretty usual in blockchain, but hard forking a blockchain is a very like time consuming process, right? You have to bring everybody together, and then you have to convince everybody. So to kind of avoid this problem, right, what Tezos has done is it has an on-chain governance, right? So when I say on-chain governance is on the platform only, you can notify everybody on the blockchain on your node only that okay, this is the update that somebody wants to push. All right, then if majority of the people agrees on the chain only, right, nothing is happening offline, right? In offline world, what happens is somebody will give the updated nodes build to everybody, then they download and then they kind of publish it, right? Here what happens is everything happens while your node is running. So you can see the update, you can see whether you want to accept it or not. Once majority of the people accept it, right, it will be accepted. So that is what is self-amending. The software kind of updates itself automatically. Correct. So see, we this is the kind of summary of the whole Tezos platform, right? We have presented issues with the existing cryptocurrencies, which I just talked about, right? Hard forking and then governance, and offered Tezos as a solution. And yeah, so while the irony of preventing fragmentation of cryptocurrencies by releasing a new one does not escape us, this is truly aims to be the last cryptocurrency, right? So when I say last cryptocurrency, what it does is it kind of updates itself to the latest of the protocols, right? So that it doesn't get old, right? And then it will be the kind of a platform, right, which does it all. That's what Tezos aims to be. This was the ICO, right? So ICO are like funding events which are still popular, right? Tezos had raised, I think, 232 millions worth of USD worth of funds. All the funds are held by Tezos Foundation, right? And then all this community, right, they can apply for the grant, right? As Om had said, you can apply for the grant and then they will approve your grant for all the work that you do. But there is not a single person, right, who is controlling whole chain or something like that. It's a whole community which is running the whole platform. So it is basically a truly decentralized platform, right? So let's just go over some of the key features, right, in terms of smart contract and all. Okay. If you have any questions, right, feel free to again post, right? I think somebody had asked, can Tezos beat Ethereum? Yes, it can beat. I do believe that it can beat, right? It has some of the good points, right, and it improves Ethereum in a very like useful manner, right? I don't have anything against Ethereum, right? I love Ethereum as well, right? But with the proof of work, it becomes difficult, right? Over the time, if everybody is doing proof of work, you will be consuming lot much of electricity, right? It becomes difficult. just to give you a comparison, right? The total, let's say, energy being used by all the Bitcoin mining, right? It surpasses the total consumption of, I think, one of the smaller nation, right, on the earth. So you can see, and this is at this stage where the adoption is not that much, right? So just think that when the mass adoption happens, right, how much energy all the miners will be using, right? So I believe that, yeah, it's not a sustainable method of doing thing. Probably Bitcoin, it may work, but for other platforms, right, it may not work. So let's say, talking about key features of a Tezos, right? So the smart contracts. So what happens in, let's say, the Ethereum, right? The contract, you write contracts in Solidity, and then it gets compiled to bytecodes. So if there is a, let's say, some kind of a vulnerability on a bytecode level, right, somebody can go and exploit that vulnerability, right, and then kind of steal money from you, right? When we talk about smart contracts, it will be holding either money or, let's say, some kind of information. So anybody can exploit this and steal money, right? So what Tezos brings is uh, smart contracts, right, which can be mathematically proven, right? So when we say, like, how mathematically proven, right, the language that we use is a Michelson, right? And what you can do is a formal verification. So formal verification is a technique by which you can kind of mathematically prove that the code that you have written, right, it does the thing which is exact, or why it was written for, right, and nothing else. So sometimes what happens is, you can, let's say, to give you a similar example, in Solidity, whatever you write, you can write a test case for that. But then, let's say, if there is a something at a bytecode level, right, you won't be able to catch. While Michelson code, I'll be showing you, right? So Michelson code, you can read and you can write test about it. And once you test that Michelson code for all the flows of your smart contract, right, then you will be rest assured that nobody will be able to exploit that piece, right? So that's what Thesis brings. Then it is upgradable, right? It's kind of a self amendment. Anybody can just go and update the submit the proposal for update, right? Everybody accepts that, and then it gets, the whole chain gets updated, right? And the person who suggests these updates, right, he also gets rewarded. And everything happens on the blockchain, nothing happens off chain, right? And the third thing is proof of stake. So this is very much important, right? When I say proof of stake is, in proof of work, you have to provide some kind of mining power, right, to do or electricity, right, to prove that you have done something. In proof of stake, you have to hold some number of coins, right, in a simple manner. And based on the number of coins that you hold, right, you will get equal probable chance of mining a block. In Tezos, mining is called as a baking, right? And Tezos uses liquid proof of stake. That means uh, even you can, let's say, if you have 100 coins, right? So you can delegate your coins to the guy who is running a node. And when I say delegating, is like, not, you won't be giving keys to him, right? But you'll be just telling you'll be delegating your rights, right? That this person would be able to use these many coins for baking. So what he does is, let's say somebody has 10,000 coins, and he's doing mining, and he's earning 8% return on that, right? What you can do is, you can delegate your 100 coins to him. So now he'll be mining with uh, 10,000 coins, and he'll be getting returns accordingly to that. And after, from that 8%, he can charge, let's say, some amount for fees, and then rest of the amount he can return back to you. So that's what is liquid proof of stake, right? A normal depose, right, that could not be possible. So that's where the Tezos has an edge over something else, right? Ripple is not a competitor of Tezos. Ripple is a complete centralized network, right? They can kind of mine as many ripples as they want, right? So Ripple, anyway, I think nobody in a blockchain world, I think there are very few people who would be considering Ripple as a pure cryptocurrency or a token, right? So that's what. Is there a possibility in either in cryptography research or implementation some weakness will be exploited and entire blockchain will fail? Yes, there is a possibility. As I told you, right? No technology or system is a kind of that secure that nobody can exploit it. Yes, it can be exploited, right? Uh, Again, you should have some way of either preventing that or kind of some kind of way, right, that you kind of bypass that, right? Basically that doesn't affect you, kind of thing. So that's the thing. What's the benefit of Tezos over Ethereum? I think I had just explained, right, all the thing. Yeah. Then crypto depend on blockchain or blockchain depend on crypto. This is again same kind of analogy as who came first, egg or this one, chicken, right? Basically. So both are kind of interdependent, right? But blockchain, what these are again my personal opinion is, you can use blockchain without any cryptocurrency, right? Because blockchain gives you a lot more than a cryptocurrency, right? Cryptocurrency is just one of the use case of a blockchain, right? So one of the use cases is just transferring of payment information or transferring of payment or storing the payment information. But yeah, so I think that probably answers your question that crypto is just one use case of a whole blockchain. Yes, blockchain, correct. I think Yash has given that uh, no, blockchain is possible without crypto. Correct. I think to answer your question, Yash. So yes, I think it's very simple, right? But then there will be some kind of a credit or some kind of a token on that native token on that platform, right? If government is running their own platform, they will have there have some own credit system, and yes, there will be some kind of currency involved in that. But you can build a platform which doesn't use any of the cryptocurrency. Yeah. Yes, definitely it can be used. Pharma related smart contracts for that matter. One of the intern who was working with us at the Tezos, right? He has developed a smart contract, right? Not just a smart contract, whole D app to store medical records on the blockchain. Yeah. So just going forward, right? I know we are just about our time, right? 3 o'clock. I'll just take, I think, 10-15 minutes or more time, right? And then we'll do a Q&A. People who want to ask questions, they can stay back, right? I'm here as long as we have questions, right? So yeah. So that's what about self-amending, right? Anybody can go and propose that, okay, these are the changes I want to do on the blockchain. Then there will be a proposal period. Then everybody will vote for that proposal, that whether they want to accept or not. If you get majority of the people, right? If you have quorum, then the proposal is accepted, and then there will be a testing period. So during testing period, what happens is a side chain is created, right, on the same node. A baker or a miner, right? It's called baker in the Tezos world, right? They don't have to do anything, right? They just have to vote whether they want to accept the proposal or not. All the side chain or testnet creation happens automatically, and once the testing period is over, right, the code will be automatically upgraded. The code on the node, right, it will be automatically upgraded, and this new code will be used, right? Correct. So the first of the self amendment, right, or the first protocol was Athens. Yeah, so it was again done by, I think, team from Europe, right? So they had to give it as a name as Athens. Then we had a Babylon, right? So this is Babylon net. It was called. Current protocol is a Carthage net, right? If somebody from the India can do it, right, then we can name the protocol as a Harappa, or let's say any civilization or any of our old this mythologies, right? Like let's say Mahabharata or Ramayana, any name you can give it. Correct. So key features are self-amendment, as we told, right? Then formal verification of smart contracts, right? So this was what I was telling on the left side we have a bytecode, right? So here you can't understand anything. You write a solidity code, it gets compiled to bytecode. So if this bytecode has some vulnerability, you can't kind of prevent it. While in Tezos world, right, you write a code in Michelson, which this language you can read it, you can write a code to kind of mathematically verify this piece of code, right? So you can kind of human readable format is also there, plus you can write some test cases around this to make sure that it never fails, right? So yeah, I think we have talked about liquid proof of stake, right? Then these are the details of a liquid proof of stake, right? Different terms like cycles and then roles and all, right? So I won't be going into detail of that, right? Because we don't know, need to know all those things as of now, right? But this is how the whole this let's say baking happens in the Tezos world. You have to have 8,000 Tezos, which is equivalent to one role to start a node, right? And if you don't have 8,000 Tezos, you can kind of delegate your coins to a guy who has 8,000 coins and then who is running a node, right? So yeah, that's how. See, there are so many baking services also running. We have a baker from India, which is a yield wallet, right? Then you can get the ratings of each baker, right? That how much efficiency do they have, right? And then it shows the expected return also. See, it is giving more return than your FDs as of now, right? Our FD rates have been dropped to 4 point something. So yeah, this is way better than that. Correct. As of now, Tezos has 467 bakers. This was again old. Now the states have been updated, right? These are, I think, 5 months old. So we have lot many bakers than that, right? And 20,000 delegators. Again, this number will be more than that. Tezos is a truly decentralized network. All these bakers, right, are across the world, right? So yeah, it is a decentralized platform, right? How to get started on Tezos, right? So I think we'll be covering all these things probably in tomorrow's session, right? And now I'll just keep it open for let's say this one Q&A, right? Have you got a link for the presentation from today to read through the last few slides that pass through quickly? We'll be sharing some documentation, right, in our channel. All this documentation is available at tezos.com, right? I'll be just putting the link, right? You can just go to tezos.com. We have taken all the material from that only, right? So yeah. Please feel free to post your questions, right? I'll be more than happy to answer. And tomorrow we will be doing some hands-on, right? We'll be writing some smart contract. I'll be explaining how you can write your own DApp. Then I'll be taking you through some of the open source tools and the bundles that we have built, right, to make your DApp journey very smooth. So I'll be explaining you all those things. I think then I can tell you that how you could be what kind of a DApp you can build with Tezos, right? Or what kind of open source project also you can build with Tezos, right? Or how you can contribute to community. Also feel free to post feedback also, right? I know 2 hours is a less and I was going with a bit of pace, right? But I think yeah, that's how it has to be done, right? Otherwise, like I don't have any other options. If it would have been a live session, right, like a full day session with the whiteboard and all, I would have taken it a little bit slow and I would be explaining uh, much things in a much more details, right? Here we are doing some high level, we are skipping many small details. But what you can do is you can go through the resources, right? By now you would have got all the terms like mining, baking, then what is a hash, what is proof of work, what is a liquid proof of stake, right? Self amendment, formal verification. Go and read about those things, right? You are welcome to join our Tezos India Foundation Telegram channel, right? Post your questions there. I think we have very active community. Everybody will be able to help and answer you all the questions.
So thanks guys for attending today's session. Thanks our speaker for this wonderful session. So tomorrow there is lot to come. Some practical session will be covered with the discussion of covering hackathon ideas and how to build apps using Tezos blockchain. So looking forward for you to join us tomorrow. Also like, share and subscribe our channel, and also make sure that you have filled the participation form so as to mark your presence. Thanks Dignesh for these wonderful sessions.
Thank you.
So we will end it now, and tomorrow we will join it again.
Yeah. See you guys
Okay.
tomorrow. Yeah, it was wonderful session.